3, Chapter 2, Definition of Enthalpy. What is enthalpy? We need to first know what is chemical energy first. Chemical energy refers to the energy stored in the bonds between electrons and protons in atoms. They include attractions between electrons and protons in atoms, as well as the repulsions between positively charged particles like the nuclei and electrons. They also include the movement of electrons, as well as the vibration and rotations of different chemical bonds. So chemical energy exists in almost all substances, cold as ice, hot as these muffins, or as healthy as these vegetables. They all have chemical energy. The unit of energy, the SI unit of energy, is joule, and in chemistry, we sometimes use kilojoules and megajoules as well. We do need to know the conversion between these three units, and from joules to kilojoules to megajoules, it's always by 1,000. So, since chemical energy is energy stored in bonds, so when bonds break, energy is required to overcome the force of attraction. And when bonds form, energy is then released. Since a chemical reaction must involve old bonds break and new bonds form, so all chemical reactions are accompanied by some form of energy change. So, if breaking old bonds requires more energy than what new bond forming can give, then overall the reaction system will appear to be absorbing energy from the environment. If it's the other way around, if breaking old bonds requires less energy than when new bonds form, then the reaction system will appear to be letting go of the energy to the environment. So, when a reaction system absorbs energy, we call it an endothermic reaction. That is, the reactants needs to absorb energy to become the products, because breaking old bonds requires more energy. If the reaction system emits energy in the reaction process, then we call it an exothermic reaction, because forming new bonds will release more energy in this case. Then reactants will have more energy than products. So what does it have to do with enthalpy? Well, enthalpy is simply a fancy name given to chemical energy of a substance. The symbol of it is H, and its units is sometimes kilojoule per mole, and in other cases, when we do not know the exact chemical component of a mixture, then we use kilojoules per grams as well. Okay? So we can't really measure enthalpy, but we can measure enthalpy change, and that is a measure of the amount of energy absorbed or released during chemical reactions. The symbol of it is delta H, and we always use the enthalpy of the products to take away the enthalpy of the reactants. So that's enthalpy change. So, for the exothermic reaction, reactants needs to release energy to become the products. So then the enthalpy change, which is the enthalpy of the products to take away the enthalpy of the reactants, will be negative because products has less energy after the energy is being released during the reaction process. Then on the other side, the endothermic reaction, the reactants need to absorb energy to become products. Then delta H will be positive because energy is absorbed.